Dear ADS3701 students, welcome to this presentation on Teaching Earth and Beyond. My name is Dr. E Mazibe, and I'm your lecturer for this module, which is in the Department of Science and Technology Education in the College of Education. The following is the overview of the module. So the purpose of the module is to revisit teachers' content knowledge of earth science and beyond. We also facilitating the development of teachers' pedagogical content knowledge for teaching the subject. And we have 4 units for this module. The first unit will be focusing on the solar system. The second unit will be focusing on what's happening beyond the solar system. The third unit then comes onto the planet Earth, and it looks at the Earth structure, the mineral resources, and also goes above the Earth surface, looking at the atmosphere. The fourth unit then brings the 3 units together in what we call pedagogical content knowledge, which is the ways of teaching a subject that makes it comprehensible to others. The assessments for the module are as follows. You will have to do assignment 1, which will be a multiple choice question on all the 4 units. You will then have to do assignment 2, which will focus on unit 1 and unit 2. Assignment 3 will focus on unit 3, and assignment 4 will focus on unit 4. We also have assignment 5, which is a contingency assignment. Please note that assignment 1 and 4 are compulsory. Assignment 5 can be replaced by assignment 2 or assignment 3. I'm going to start with the solar system, which is something that you have to know in this module. Remember, I said we will be revisiting teachers' content knowledge of the content of the earth science and beyond. So it is important for you as the student to understand our solar system, the solar system where we find our home. So we describe basically a solar system as the collection of objects that are gravitationally bound to the sun. As shown in the diagram, you can see that we have the sun in the center. Please note that the diagram is not drawn to scale, but we have the sun in the center of the solar system, and it is surrounded by 8 planets. There are 4 terrestrial or rocky planets, which are Mercury, Venus, Earth, and Mars. But we also have 4 Jovian gaseous planets, which are Jupiter, Saturn, Uranus, and Neptune. Now, between the Jovian and the terrestrial planets, we find an asteroid belt, which is between Mars, the last terrestrial planet, and Jupiter, the first Jovian planet. And we also have the Kuiper belt, which is in the outer edge of our solar system, as well as the Oort cloud, which is the shell that is surrounding the entire solar system. It is important to understand how the solar system formed, and the theory that describes the formation of the solar system is known as the nebula theory. Now, the theory basically tells us that everything that we have in our solar system formed from dust, which is a nebula. Nebula is Latin for cloud. And the nebula was initially beyond the orbit of Pluto, which means it had a very low density at the time. But then gravity exceeded the tendency to pull the gases together, causing them to increase in terms of density, and that's how basically the sun and the planets were formed. So the nebula started rotating because the galaxy is also rotating. So the galaxy that we find ourselves in is rotating. And the rotation resulted in spinning, and the spinning resulted in flattening. For example, you know what happens when you take dough and you spin it when you're making pizza. The more you spin it, the more it gets flat. So that's what happened. Then the center of the nebula basically formed the sun, and the surrounding disk formed the planets. And the inner planets formed from material that remained solid at high temperatures, for example, iron. And then the outer planets consist mainly of hydrogen and helium gases far away from the sun. And then we will have a discussion on the center of the solar system, the sun, which has a mass of 2 times 10 to the power 30 kilograms and a diameter of 1.4 million kilometers. It produces energy from the thermonuclear fusion of hydrogen into helium. And this is what happens each second, okay? About 657 million tons of hydrogen fuse into 653 million tons of helium. The 4 million tons of mass that is lost is discharged as radiant energy, and this is what we get on Earth. Now, solar energy is generated deep in the sun's core, which is 10% of the sun's total volume. And the core is extremely hot at about 1.5 times 10 to the power 7 kelvins. And what we know about the sun is that it is so hot that matter exists in the plasma state. The plasma state is basically where you find matter in the form of ions and electrons rather than atoms and molecules. Because it is so hot, atoms cannot stay together and molecules basically cannot remain molecules. They get broken down into the charges that make them up. The sun's atmosphere is known as the chromosphere, and the outermost region of the atmosphere is the corona, and the temperature is 1,000,000 kelvins, and this is where X-rays are formed. The sun also produces solar winds. These winds come from the corona of the sun, and they power aurora, and they produce tails of comets. And then we'll move on to the planets. Now we'll start with the inner planets, and we'll present them in the order in which they are lined up from the sun, starting with the closest planet to the sun, which is Mercury. Mercury is about 1.4 times larger than the Earth's moon, and it's similar in appearance. If you look at a picture of Mercury and you look at a picture of the moon, you'd see that the two basically look pretty much the same, and they are pretty much the same size. This is the closest planet to the sun, and it is the fastest planet circling the sun, only 88 Earth days. Okay, we know that it takes us 365 days to circle the sun once. It takes Mercury only 88 Earth days. Okay, now it has 3 spins about its axis for 2 revolutions about the sun. Okay, and that makes the daytime to be long and hot, up to 430 degrees Celsius. The reason why that happens is because it has 3 spins about its axis for 2 revolutions about the sun. Remember that here on Earth, we have a complete spin in just 24 hours, which is what gives us a day, and which is what gives us daytime and nighttime. But then in terms of Mercury, there are 3 spins for 2 revolutions about the sun. Okay, so that makes the days and nights extremely long, and then daytime gets to be so hot simply because the planet is closer to the sun, so it gets intense radiation from the sun, and that raises the temperature. And the side that is facing the sun during the day, raising the temperature to 430 degrees Celsius. It also has a very weak gravitational field, which means it has very little atmosphere. And the fact that it has very little atmosphere, it means it has no blanket of the atmosphere or winds that will transfer the heat to the nighttime side. Therefore, nighttime on the planet is extremely cold, about minus 170 degrees Celsius. Now it is fairly bright in the night sky. It appears as an evening star between March and April, and it also appears as a morning star between September and October. It is seen near the sun at sunrise or sunset. And then the next planet is Venus. This is the second planet in the solar system. This is frequently the first star-like object to appear after sunset, known as the evening star. It basically resembles our planet in size, density, and distance from the sun. It is much closer compared to the Earth, but if you look at the planet itself, in terms of size and density, then you would see that it pretty much resembles the Earth. That's why some uh, scientists believe that it describes the future of the Earth if we do not take care of it. Okay, the planet has a very dense atmosphere. 96% of the atmosphere is carbon dioxide, which is an opaque cloud that generates high temperatures of about 470 degrees Celsius. We know that carbon dioxide is a greenhouse gas. The more you have carbon dioxide, it simply means that you will have the globe or the planet warming up. We use the term global warming to describe the fact that the globe is warming up because the gases will absorb heat and then send it back to Earth instead of allowing it to escape back into the atmosphere. Now, the atmosphere and the close proximity with the sun makes Venus the hottest planet in the solar system. The hottest planet is not Mercury. Mercury is also hot during the day, but Venus is hotter, okay, because of the atmosphere that it has. Remember, Mercury pretty much has no atmosphere. Uh, Venus has a very dense atmosphere, okay? Now, Venus takes 243 Earth days to make a spin, which is to complete a day, and 225 Earth days to make one revolution, which is to complete a year. So that's an interesting fact about Venus. This tells you that a day on the planet is longer than a year on the very same planet. Okay, then we bring it home, planet Earth. This is where we are. This is where you're listening to this presentation from. Okay. Now, this one resides in the habitable zone, neither too close nor too far from the sun, which makes water to remain liquid. The planet is known as the blue planet. About 70% of it is water. Is covered in water. The surface, about 70% of the surface is covered in water. The oceans also support the carbon dioxide cycle, the thermostat that keeps our temperatures suitable. Okay. Remember, we talked about the sun being in a plasma state, meaning it also sends out solar winds, the charged particles that are part of the matter in which it is made of. Now, the Earth has a magnetic field, which is called the magnetosphere, which extends thousands of kilometers into space. Now, the solar winds that are coming from the sun are basically sent out in every direction. We are lucky to have the Earth's magnetic field, which basically protects us from these solar winds. Okay. If we didn't have the magnetic field, we wouldn't be here. The atmosphere would have been stripped out and we wouldn't be able to, there wouldn't be life at all on this planet. And then the next planet is Mars, which is more than half the size of Earth, and it's 1/8 of the Earth's mass. Okay, it has a thin, nearly cloudless atmosphere, a crust, mantle, and a core. And what scientists have found on the planet is that it has ice polar caps made up of carbon dioxide solid and seasons twice as long as those of the Earth. Now, the atmosphere, just like Venus, is 95% carbon dioxide and about 0.15% oxygen. But the difference is this atmosphere is very thin. Therefore, it doesn't trap heat. So during the day, remember that during the day, it simply means the side is facing the sun. Therefore, the temperature there is about 30 degrees. But at night, where the other side is facing away from the sun, it gets extremely cold, about minus 130 degrees Celsius. This planet, just like our own planet, has, in fact, this one has two moons. We have one. Mars has two moons, Phobos, which is the inner moon, and then Deimos, which is the outer moon orbiting the planet. And then remember in the beginning, I talked about the asteroid belt, which is between Mars and Jupiter. So this is basically what the asteroid belt represents or is made of. So this is basically a collection of rocks located between the orbits of Mars and Jupiter. And there are about 150,000 asteroids that have been cataloged, with many yet to be discovered. They come in different shapes and sizes, of course, with Ceres being the largest asteroid and is less than 1,000 kilometers in diameter. Can already imagine how big that must be. If you think about 1,000 kilometers, that is a very huge distance. And if you were to think about an object that is in space with that diameter, then you can already imagine how big that must be. It's significantly small compared to planets, of course, but it's significantly big compared to the things that we see on planet Earth. Okay. Now, massive Jupiter, the planet, the biggest planet in the solar system, is believed to have disrupted the orbits of the material, sending it off in many directions, including towards other planets. And the two moons of Mars that I have discussed earlier may have been former asteroids. It is believed that they may have been former asteroids. Now, Jupiter also causes asteroids to collide and break into smaller fragments, and this is where it gets interesting. Now, these asteroid fragments are known as meteoroids, okay? And they at times make their way to our planet Earth. However, we have an atmosphere. Remember that we have a magnetic field that protects us from solar winds, but we also have an atmosphere that bends these meteoroids as they make their way into the Earth. Now, the atmosphere causes friction that heats them white hot. Now, as they descend with a fiery glow, you can see the diagrams on the left-hand side of the screen, which the picture in the middle basically shows the meteoroids as they descend with a fiery glow, where they are now called meteors. Now, if a meteor is large enough, it may survive and reach the surface of the Earth, where it will now be called a meteorite. And I have a picture at the bottom which shows a crater that was formed by a meteorite back in ancient times. Now, about 200 tons of smaller meteorites hit the Earth daily, but they're quite small to cause damage. Now, every 10,000 or so years, we are hit by meteorites big enough to create a crater. Now, in South Africa, we have four big craters. The crater de Tswaying, the Vredefort crater, which is pictured, it's actually pictured on the left, the Morokweng crater, and Galkop. And the demise of the dinosaurs is believed to have been caused by a meteorite 65 million years ago. And then we have our outer planets. The first one is Jupiter, the biggest planet in the solar system, with a diameter that is 11 times that of the Earth, and its volume is 1,000 times that of our planet. Its mass is 318 times that of the Earth, and its density is low. Okay, it is a gaseous planet. So gaseous planets have low density compared to rocky planets, for example, the planet that we find ourselves in. So its density is a quarter of our density, and it is made up of 82% hydrogen, 17% helium, and a percentage of a percentage of the other gases, for example, your ammonia and other molecules. The core is 15 times as massive as the entire Earth, which is made up of iron, nickel, and other minerals. Now, more than half of Jupiter's volume is an ocean of liquid hydrogen. Now, beneath the ocean, an inner planet of hydrogen is compressed into a metallic state. Jupiter has more than 60 moons in addition to a faint ring. And the next planet after Jupiter is Saturn, which is the second largest and massive planet. This one has a diameter, excluding the ring system that it has, which is 10 times that of the Earth, and its mass is 100 times that of the Earth, composed primarily of hydrogen and helium. and the lowest density of all planets, which is only 0.7 times the density of water. This means that if you could have a bathtub as huge as the planet, you could put the planet in the bathtub with water, and the planet would float. Okay, that's how that's how much density or how little rather density it has. Now the rings have a diameter of about 270,000 kilometers, while it has a thickness of about a kilometer, and the rings are composed of frozen water and rocks. Now, these are believed to be materials of a moon that never formed, or materials that got torn apart by tidal forces. Okay, and then the next planet is Uranus, which is twice as far from the Earth as Saturn is, and its diameter is about 4 times that of the Earth. Its density is slightly greater than that of the water. Has CH4 in the upper atmosphere, which absorbs uh, red light, giving Uranus its blue-green color. If you look at the diagram on the left-hand side, you can see that it appears to be bluish. So the methane that is in the upper atmosphere absorbs red light. Remember that light comes in different colors, Roy G. Beef. Now, if the red is absorbed, you're getting more of the blue side, and that's how the planet appears to be blue. Now, its axis is tilted 98 degrees to the perpendicular of its orbital plane, so it lies on its side. Different from the other planets, it is tilted about 98 degrees to the perpendicular. It is believed that that must have been caused by a collision with a larger body earlier on in the solar system's history. Now it appears not to have an internal source of heat, and therefore it is extremely cold, and it's far from the sun, so it is very, very cold. And it has at least 27 moons in addition to a complicated faint ring system. You can see the faint ring a bit in the diagram. And it has 27 moons as indicated in the slide in addition to that. And then the next planet is Neptune, with a diameter of 3.9 times that of the Earth, and its mass is 17 times that of the Earth. But look at the density, only a third of that of the Earth. And its atmosphere is mainly hydrogen, helium. It has some methane, it has some ammonia, which make it slightly bluer than Uranus. It also has it has 30 moons in addition to a ring system as well. Its largest moon, Titan, orbits Neptune in 5.9 days in the opposite direction to the planet's eastward spin. This suggests that Titan is a captured object stolen from space, and its diameter is 3/4 that of the Earth's moon, and its mass is twice that of the Earth's moon. It has bright polar caps and geysers of liquid nitrogen. Now let's talk about life in the solar system, life on the planet that we are on, and what makes where should we look, in fact, for life in the solar system? What makes a body suitable for life? So we're going to start. We will start with the planet that we're on, because it basically helps us understand what makes the planet suitable for life. Now, life on our planet is carbon-based, okay? And carbon bonds to as many as 4 atoms at a time. If you go to chemistry, you'll understand that carbon has 4 valence electrons that are unpaired. Therefore, it can make it can bond with as many as 4 atoms at a time. Now, it therefore serves as the basis of a wide variety of complex molecules. Now, other elements such as hydrogen, nitrogen, and oxygen that combine with carbon to make biomolecules are also important. We need energy. In our case, the energy is from the sun. In the entire solar system, then you will believe that the energy is from the sun, particularly if the planets are closer to have enough energy from the sun. But also, the energy can be from chemical reactions or inside on or inside the planet, as well as tidal forces. Now, life is believed to have needed a liquid medium such as water so that the molecules can move around and react with others. Now, the fourth condition that we need is stability. We need enough time for life to develop and evolve. Now, where should we look for such conditions in the solar system? Well, many of the bodies here satisfy the needs for the right elements and an energy source. We all have the sun, the other planets, Mars, Venus, Mercury, any other planet is basically exposed to the sun during the day when that side is facing the sun. Uh, but in contrast, the presence of water is relatively rare in many other planets. Mars is believed to have had water once because its poles are still covered with ice. Now, the presence of water also implies that it was warmer and almost habitable. But was it inhabited? That is a big question. Now, bacteria-like fossils were discovered in a Martian meteorite, and some scientists basically are of the belief that life on Earth actually started on planet Mars, which is the first planet to have water. So the life that we're living here on Earth, according to these scientists, did not start here. It started on the planet that was the first to have water, which is Mars. But how did it happen? Well, it is believed that pieces of Mars may have been knocked off via impacts. So the planet must have collided with other bodies in the earlier time of the solar system, and its pieces were broken and landed in other planets, for example, uh, the Earth. However, this is a contested debate with research still ongoing to basically come up with solid evidence and explanations whether the life that we live here on Earth basically started here or it started on planet Mars, because that is the first planet to have that was the first planet to have water. Then we now come to our own planet and discuss it in greater detail. The first thing is the seasons of the Earth. Okay, uh, what causes the seasons of the Earth, and what basically gives us daytime, what gives us nighttime, what gives us the different seasons. That's what we'll be discussing here. So we'll start our discussion with the spin of the Earth. Now, as shown in the diagram there, you can see the arrow that shows that the Earth is spinning. Okay. Now, as the Earth spins, one side of the Earth will be facing the sun, the other side will be facing away. Side that is facing the sun, that is daytime. The side that is facing away, that is nighttime. Now, the spinning of the Earth gives us day and night, but the orbit of the Earth gives us of the orbit around us of the Earth around the Sun gives us years and also seasons. Now you can see from the diagram that the Earth is tilted. It is tilted at 23.5 degrees with the vertical. Okay, this follows from a collision that it was involved in. You will see this in the discussion of the formation of the moon. So it is believed that the Earth collided with another body back in the day, and that collision basically changed its axis of rotation. Okay, and that tilt remained fixed over the years. It is still fixed now, and it remains fixed as it orbits the sun. Now, the seasons are caused by the intensity of the sunlight that is received by different regions on Earth. We know that summertime is associated with heat, with intense heat. Therefore, summertime should occur when the hemisphere is tilted towards the sun. Look at the diagram on the left-hand side at the bottom of the screen. You will see that you have the Earth that is shown on either side of the sun, and it's tilted the same way. And at the bottom of the diagrams, you have an indication that the angle is 23, it's actually 23.5 degrees with the vertical axis. And you can see that at some points, it is the southern hemisphere that is facing towards the sun, meaning it gets intense sunlight, and that makes it the summertime. And then in other instances, you find that the same southern hemisphere is now facing away from the sun, which means it doesn't get that much sunlight, and that becomes winter. So winter occurs when the hemisphere is facing away from the sun. Now, autumn and spring occurs halfway between summer and winter, and this is where when the Earth moves in such a way that the sun's intensity changes from one extreme to the next. So you have one hemisphere being facing the sun and getting intense heat. At some point, obviously, as the Earth moves around the sun, you find that there is now a change. But before you move from intense sunlight to little sunlight, there should be a halfway point where you're getting uh, uh, sort of average heat intensity, and that's what that is basically described by your um, autumn and your spring. Okay, now as the Earth orbits the sun, we have solstices and equinoxes that occur. Now, solstice occurs when the sun's path in the sky is the furthest north or the furthest south from the equator. Okay. Now, in South Africa, where we find, I believe many of us find ourselves, this happens in December. This is where we get the summer solstice. And then in June, we get the winter solstice. And it is around the 22nd of those 2 months. Now, this describes the longest and the shortest days of the year. So the 22nd of December basically represents the longest day uh, in that particular year, and then the 22nd of June will represent the shortest day that particular year. Okay, and equinoxes now occur when the celestial equator intersects that of the sun, and this is where days and nights are equal. So in December, it's the longest day. In June, you get the shortest day, but then halfway between those 2 months, either from June to December, you will get, in March, you will get a day that has the same amount of daytime and nighttime. Okay, remember I told you about the tilting of the Earth, and I said it is believed to have been caused by an impact. Now that impact led to the formation of the moon. Okay. Now, the moon is composed, its composition, or the composition of the moon, is nearly the same as that of the Earth's mantle. It also possesses a rather small iron core. Now, the giant impact theory explains the formation of the moon. Now, this is what the theory basically states. In the early days, the Earth had a Mercury-sized companion closer to its orbit. Now, the companion was closer to the sun, and thus it orbited faster. So the closer you are from the sun, the closer you are to the sun, rather, you will orbit much faster. We've seen Mercury that it takes 88 days to orbit the sun. Okay. Now, after passing the Lagrangian point, now the Earth's gravitational pull became stronger, holding it back, and then they orbited in unison. So basically what happens is, at some point, as this planet, the Mercury-sized companion, was orbiting the sun, it got to a Lagrangian point, which is where the gravitational forces of different objects influencing that one object balance out. Okay, so the Earth's gravitational pull rather became stronger there, and then it held on to this uh, uh, Mercury-sized companion, and then they started orbiting in unison. Now, a random event, for example, the passing of an asteroid or comet, caused the companion to fall off that Lagrangian point, and it started falling towards the Earth. Now, the collision of the two spewed debris everywhere while turning the Earth fully molten. So the Earth was uh, fully molten after the collision, and the debris collected as a ring around the Earth and coalesced into the moon. Okay, so that's basically the story of the moon. You can read more on this from various sources, but briefly, that is the story. Now, this is what you need to know about the moon. It has a diameter which is a quarter of that of the Earth. Okay, it doesn't have water. It has very weak gravity to have an atmosphere, and the fact that it doesn't have an atmosphere, it means it has no weather, it has no sound, and it has no erosion of craters, no erosion of any evidence. You can go on the moon, write whatever you want to write, and come back on Earth. You can go back to the moon many years later, you'd find that what you wrote is still there. But if you go to the beach here on Earth and you write your name and you write whatever you want to write, take pictures, without even having the water sort of cleaning up or distorting your writing. With time, the atmosphere, the fact that there is wind blowing, would change the writing that you have put on the surface of the earth at the beach. Okay, but the moon doesn't have an atmosphere, so it has no weather, it has no erosion. Okay, now the footprints of the people that went to the moon are still there. The American flag was tied on a horizontal pole so that it appears as if it is waving, and it is still there. Okay, um, it doesn't because there's no atmosphere and the moon wouldn't appear as if it is waving. They had to have a horizontal pole so that they fasten it onto the pole and having it appear as if it is waving. You've seen that when you look into the night sky and you see the moon, it appears to be different in different times. You look at the moon and you see a full moon. Sometimes you don't see the moon. Sometimes you see a half of the moon. Sometimes it appears as if it is a banana on one side and then the banana is now on the other side. These basically describe or basically indicate that we don't see the moon the same way each time. And that is described as the phases of the moon. The most important thing that you need to understand is the fact that half of the moon is always bright all the time. Just like planets, half the planet is bright each time. The side that is facing the sun will always be bright. And the moon has a side that will always be facing the sun. Okay. Now we always see different amounts of its sunlit half as it circles the earth each month. Now the cycle begins with the new moon. If you look at the diagram on the left hand side, you can see you have the sun indicated by the gold or yellow rays here, meaning the sun is on the right hand side of your screen right now. And then you have the moon on the left hand side of the diagram and the earth in blue. So what you need to understand is we will be starting with a new moon. This is where it starts, okay? Now the new moon is where the sunlit part is on the other side. It's behind us. So we standing on the earth and you find that the sun is behind the moon and the sunlit part doesn't show its face on the earth. So we don't see it. That is the new moon. But if you look at the diagram, as the new as time goes, and you find that the moon has now moved, it is now in a waxing crescent phase. Now we see the sunlit part, but not the whole half that is sunlit. We just see a crescent, and it's a waxing crescent to show that it is increasing. The crescent is increasing. This happens during the next 7 days from when it was a new moon. Now it continues to move. Now this is what leads to the first quarter. It's called the first quarter because even though half of the moon shows, we don't see the entire half. We basically see a half of that half. So what we're seeing is basically a quarter. So that is called a first quarter. And then afterwards, what we see is now most of the sunlit part, more than half, and that is known as the waxing gibbous. Waxing means increasing and gibbous basically means more than half. So we see more than half uh, of the compared to the previous phase. So in the previous phase, we were seeing a half of the half. Now we're seeing more than the half of the half. Okay, and then it moves into the full moon. So now we are seeing the entire half of the moon that is sunlit. Okay, that is known as the full moon. Okay, and then after that, we're now getting into the waning gibbous. You can see that the dark side of the moon now starts showing and the bright side starts decreasing. Now it is waning. Waning simply means shrinking, but it's still a gibbous because it is bigger than uh, the half of the half that we are able to see. And then with time, it moves into the third quarter. Now, in the third quarter, just like in the first quarter, we're seeing a half of the half that is sunlit, okay? Now, and then after that, we move into the waning crescent. Waning means it's decreasing, okay? And the crescent is basically less than the half, okay? And then it goes back to the new moon and so on. So the cycle basically repeats each month. Now, the entire time for one complete cycle is about 29.5 days. And if you are in the southern hemisphere, which is where I am situated as I'm making this presentation, to understand the next phase of the moon, just know that the moon follows the COD cycle. And then if you are in the northern hemisphere, it will be the DOC, which simply means you will see something that looks like D. For example, if you look at the first quarter, you can see that the sunlit part sort of resembles D. And then the O is basically shown by the full moon, and the C is shown by the third quarter. Look at the sunlit part. You'd see it shows DOC, but then if you're here on Earth, it will be COD. That's how you know. If you look into the sky and you want to know, since this is now the full moon, what is the next phase, or where is the sunlit part going to be? Is it going to be on the left, or is it going to be on the right? Then you just use that COD if you're in the southern hemisphere, and DOC if you're in the north. Now the diagram in the next slide shows it from the northern hemisphere. Now, why do we always see one side of the moon? Now, we always see the same side of the moon. Okay, before we go into that, it is important to note that because we see one side of the moon, it doesn't necessarily mean that the moon is not spinning. Okay, the moon is spinning. Okay, but its spin and orbit are exactly matched. Okay, so it takes the same time to spin as it does to orbit the Earth, and therefore only one side shows each time. But why does this happen? It's because of torque, which is caused by the gravitational forces exerted by the Earth on the moon. So the side that is closest to the Earth gets pulled stronger than the backside of the moon, according to Newton's law of universal gravitation, which tells us about the relationship between force and distance. So the side that is closer to the Earth experiences a greater force compared to the backside, okay, because of distance. And if it happens that the side basically tries to move out of alignment, the torque will pull it back. And as a result, the one side that has been locked into the sun because of the gravity will remain locked for as long as the moon orbits the Earth. So if this ball's long axis, okay, the ball that I'm talking about here is like a rugby ball. So basically, the gravitational force makes the moon look like a rugby ball pointing towards the Earth. Now, if this ball, the ball's long axis is out of alignment with the Earth's gravitational field, a torque from gravity will act on it, and it will bring it into alignment. Now, I want to move into the discussion of eclipses. The sun's diameter is about 400 times that of the moon, but its distance is also 400 times the moon's distance from the Earth. So if you look at the two objects in the sky, it appears as if they're pretty much the same size. They're not. The sun is significantly big, but it is also significantly far. Okay. Now, an eclipse occurs when the Earth and the moon enter the shadow of each other. So in the solar eclipse, it is the moon's shadow which falls on the Earth. So the moon gets in the way of the sun from reaching the Earth. Okay. Now, because of the size of the sun, the rays that will land on the Earth will form an umbra and a penumbra. Okay, now this is what happens. If you look at the diagram on the left-hand side, the diagram at the top, okay, what you're getting there is basically a solar eclipse. So you will be on Earth, okay? If you look at the diagram, it shows that the shadow is somewhere in West Africa, okay? Now the moon is in the way of the sun, okay? So it blocks the rays. But you can see that because the moon is the sun rather is so big, its rays, some of its rays, of course, will get into will make way into the surface of the Earth, and some of the rays will give us what we call the penumbra, okay, where you will still get a partial eclipse, but it wouldn't be completely dark. And in some instances, you find that the rays basically are cancelled out completely. Here you get rays that are blocked by the moon, but then you also have rays that are coming from the other side, so it gets slightly brighter. And then you have instances where all rays are blocked completely, and this is the umbra. So this is where it gets completely dark. If you happen to have an experience of witnessing this, then you consider yourself very lucky. This is a very rare event. Now, if you look at the diagram at the bottom of the screen, you can see that it is now the Earth that has gotten in the way of the sun's rays um, from reaching the moon. Okay, this is known as the lunar eclipse. It is also rare, but not as rare as the solar eclipse. Okay, both the solar and lunar eclipse are rare events, unlike moon phases that occur every month. Why is this the case? Now, the most important thing to note is that in order to get an eclipse, you need the sun, the earth, and the moon to be perfectly aligned. Okay. Now, remember that the earth's orbit, or the earth orbits the sun while the moon orbits the earth. And the two orbital planets, the earth has its own orbital plane around the sun. The moon has its own orbital plane around the earth. And those two planes are actually at an angle of 5.2 degrees relative to each other, as shown in the diagram in the next. There's a diagram that I'm missing here. Okay, here is. Oh, the diagram doesn't want to show. Okay. Okay, I'll just explain this like this without basically putting it in presentation mode because it refuses to show the diagram that I want to show. Okay, now if you look at this diagram here, you can see that you have the Earth and you have the moon, and this rectangle here basically shows the plane of the Earth, and then this circle here basically shows the plane of the moon. Okay, and here's the angle of 52 degrees that is between the two planes. And I've also redrawn the diagram at the bottom basically to show you that this is a very rare event because of that angle of 5.2 degrees. So you can see the Earth is at the center. You can see the moon on the right-hand side is above the Earth, and then on the left-hand side is below. The sun is not shown, but the sun's rays basically tell you that the sun is currently on the right-hand side. Okay, so like I always say, one side of any object will always be bright because that's the side that's going to be facing the sun. The other side will be dark. Okay. Now, that side that is dark is also the side that's going to have the shadows. And you can see that the shadows of the new moon are basically missing the Earth. I've indicated there that the shadow misses the Earth. And then if you look at the sun, so I'm moving from the left or from the right to the left. So I start with the new moon. You can see that the shadow of the moon basically misses the Earth. And then in the middle, you have the Earth, and its shadow basically misses the full moon, which is now on the left-hand side. And its shadow is basically facing in the same direction, and it has basically nothing to land on. And the next discussion now is the discussion of tides. This is something that you would experience if you go to maybe you visit a coastal area and you look at the shores, the water that basically how far the water reaches from the ocean. Okay, so that basically is described by tides. So tides are the rise and the fall of the sea level. This is caused by the combined effects of the gravitational force of the moon and that of the sun. So if you look at the diagram that I have on the left-hand side on top, you can see that it shows the Earth, it shows water, it shows the moon, and it also shows tides, low tides and high tides. Okay. Now, the gravity of the moon exerts a tidal force causing the Earth's water to bulge towards the moon. So where the moon is, the moon exerts a gravitational force on the water, on the planet Earth, and then it causes the water of the Earth to bulge towards it. Okay, which creates a high tide facing the moon. And if you get a high tide that is now facing the moon, the other side or the other part, the top part and the bottom part of the Earth will have low tides. Okay. Like I said here, this creates a high tide on the side of the Earth facing the moon and on the exact opposite side of the Earth as well. You can see that here on the exact opposite side of the Earth, you also get a high tide. So you may find that you are on a beach and you don't even see the moon, but you still get a high tide where you are because the moon is on the opposite side and is creating a high tide on that side, and you are also getting a high tide wherever you where you are on the opposite side of the moon. Okay, now the region that loses the water will then experience a low tide. This is 90 degrees to the direction of the moon. You can see the moon is here. And then if you move to the center of the earth and you move up or you move down, that is an angle of 90 degrees, okay? Now this is what creates the two low tides and the two high tides in a day, which are all separated by about 6 hours. We know that a day has 24 hours, but we are getting 4 tides. So you get a high tide twice and you get a low tide twice. So if you can uh, sit still in the same spot and basically observe the tides, you would notice that they change 4 times in a day, all separated by about 6 hours. Now, this is a misconception that many students tend to have. They believe that tides change the density of the water. No, tides do not change the density of the water. Instead, they change the level of the water. As shown in the diagram here, you can see a low tide. So the water doesn't rise that much because it has risen somewhere else. So here, what you will be getting is a low tide. But then when the moon is now, or when you are on the side that is now facing the moon, or on the opposite side as that is facing the moon, then what you will be getting there is a high tide. And what that means is the moon will exert a gravitational force and it will cause the water to bulge towards the moon. And as a result, you will have an increase in the water level. And this is basically a high tide. So thank you for staying and watching until this point. This is basically the first unit of the module focusing on the solar system. So thank you for tuning in. Until next time.